Alright, let's talk about some rotational symmetry and rotations. So first we're going to start with rotational symmetry, and what that means is I can take a figure and I can rotate it before I get back to the original and it'll look the same. So when I say get back to the original, I mean go around 360 degrees. So I got a couple shapes here, a square and a star. So I'm going to put a little dot. No, I'm not going to do that. So what you have to do is think about taking this shape and turning it so I turned that 90 degrees and I still have what looked like what I started with. So on the square it has rotational symmetry of 90 degrees. So that's how far you can turn it to get back to what it looked like originally. So if I only turned it, 45 degrees, it wouldn't look the same. But when I turned it 90 degrees, it then looked like what I started with. So same thing with the star. I have the point pointing up, so I'm going to rotate this till the point turns up. And I can do this. So this is my original point. I'm going to put a little dot on my original point just so we can keep track of it. So that was 1, 2, 3, 4, and then 5. So 5 turns to get back to the original. So in order to find how many degrees that has rotational symmetry upon, you just take 360 and divide it by how many turns it took to get back to that original, which was 5. So we just do 360 divided by 5, so that'll go in 7 times, which is 35, subtract, I get 2, so it'd be 72 degrees as our rotational symmetry. Alright, so now we're going to take that figure and we'll call it ABCD. And we're going to rotate it counterclockwise about the origin. So what you can picture in your mind is taking this whole shape and just turning it 90 degrees counterclockwise. So that's what it would look like. So now we have to recreate that shape on the graph, going back to what it originally looked like of this. So you see it again. So it's going to go diagonally on the top and bottom, and then vertically on the sides. Alright, so let's draw that. Alright, so then we put in our prime symbols, A prime, B prime, C prime, and D prime. So let's look what happened with our numbers. So first we started out with A, B, C, and D. Let's put those coordinates in. So A was 2, 2, B was 3, 5, C was 6, 5, and D was 5, 2. And then after our rotation, A becomes negative 2, 2. B becomes negative 5, 3. C becomes negative 5, 6. And D becomes negative 2, 5. So the rule on a 90-degree rotation, we started with our XY, and it changed to, if you look at D, 5 and 2 switch places. So X and Y switch places, and then the Y value, whichever that one was, becomes its opposite. So XY becomes negative YX. So let's look at another one. Let's see what happens when we do a 180 So again, just picture this whole thing going 180 degrees. That's what it's going to look like. So we'd have a point, A would be at -2, -2. So let's rotate this back around. Let's get a different color for this. So A double prime. It's double because we've done it twice. Alright, so let's put our original points there, again, just so we can see them. So originally we started with 2, 2, 3, 5, 6, 5, and 5, 2. And our new points are -2, -2. B is at -3, -5. C is at -6, -5. And D is at -5, -2. So if we write a rule on this, we started with the XY, and it changed to, if you look at, we'll look at D again, 5 became -5, 2 became -2. So they didn't switch values, they just became their opposites. So when you have a 180 degree rotation, the values are going to change to their opposites. Alright, and we can also do a 270 degree rotation, but I'm not going to do that today. We'll save that for another day.